to my YouTube channel, Massa Tutorials. In this video, we'll be looking at what elementary calculus, and under that, we'll be looking at differentiation of simple trig functions. Differentiation of simple trigonometric functions. So now, note, we have if you differentiate sine x with respect to x, you get what? Cos x. Alright. We have proofs for all these trig functions here. When I have time, or when I get enough time, we'll do all the proofs so that you know that it's not just there like that. You understand that? It didn't come by chance. There are proofs to show you that when you differentiate tan x with respect to x, you get sex squared what x. So they are proofs. Alright, so I said that when you differentiate sine x with respect to x, you get cos x. When you differentiate cos x with respect to x, you get minus sine x. When you differentiate sec x with respect to x, you get sec x tan x. When you differentiate cot x with respect to x, you get minus cosec squared x. When you differentiate cosec x with respect to x, you get minus cosec x cot x. Don't forget, it is very, very important. When you differentiate sine x, you get cos x. When you differentiate cos x, you get minus sine x. Likewise, when you differentiate tan x, you get sec squared x. When you differentiate sec x, you get sec x tan x. When you differentiate cot x, that's the complementary of what? Tan x. That's the complementary of what? Tan. So when you differentiate cot x, you get the minus cosec squared x. When you differentiate cosec x, you get your minus cosec x cot x. Alright, so now let's start with examples. Examples so that you know what we are doing. Alright, so now let's see. They said work out the derivatives of the following trig functions. You should work out the derivatives of the following trig functions. So one, we have cos x plus sine x. Two, we have 3 minus cos x. We have 3 cos 5x squared plus 2 cos cubed x, 2 cos squared x squared plus 1 sine squared x squared plus 1, 2x cubed cos 3x cos 2x divided by sine x, tan x divided by x, sine x cos 2x, 2 sine cubed x cos x squared minus 1 minus x sine x all over root of x, then x squared over sine x. They are very, very simple, very, very trivial. You just follow me so that I solve at least, let's say at least 5 or examine 5. Okay. Alright, so now let's see. Solution. We are starting with the first one. Cos x plus sine x. Right? They are all in terms of what? X. They are all in terms of x. And you want to find what? Dx. Right? You want to differentiate with respect to what? X. So now let's see how best we can do that. Alright. So you can see that we have 2 terms here. So we have to differentiate it with 10 by 10. So I have dx of cos x, then plus dx of sine x. So we have this. Right. So now, when you differentiate this cos x with respect to x, you get minus sine x. Then plus, when you differentiate this sine x with respect to x, you get cos x. So we have cos x. So this guy is the answer. Or you can write it as what? Cos x, you have to bring the positive aspect first, and minus sin x. So we have that. That's the angle. So we have that. Let's proceed to the next question 2, and let's see. Alright, so let's see. 3 minus cos x. How do we differentiate that? So we differentiate 3 with respect to what? X minus, we differentiate cos x with respect to what? X. Right. So now, when you differentiate this 3 with respect to x, it's a constant. There is no x term here. So it goes to what? 0. Minus, when you differentiate cos x with respect to what? X, you get what? Minus sine x. Right? Minus, you get what? Cos 0. So 0 plus sine x is the same thing as sine x, which is very, very simple and very, very trivial as well. Let's move on to question 3. Let's see this question. Question 3. 3 cos 5x squared plus 2. Watch very well as we tackle this question. Now, see something. You can see that this time around 3 is not adding, or cos 5x squared plus 2 is not adding to it 3, but this time around it is what? Multiplying. And this 3, there is no x term available. There is no x term here, right? So it means that this 3 is a constant, but it will never go to 0 because it is what? Multiplying, right? So if it is multiplying, then what do? You can factorize 3 out. Now, what I'm saying here again is 3 is multiplying itself to this trig ratio, which is cos 5x squared plus what? 2. Now, it is not adding, or they are not adding, right? So we can only say that this 3 will go to what? 0. It can never be possible. Now, if this 3 cannot go to 0, then now this 3 here, there is no x term there. So which means that this 3 is what? It's a constant. And because they are multiplying, you can factorize this 3 what? Out. So now, this is how we do it. So I take my dx of 3 cos 5x squared plus 2. So I can factorize 3 out. So 3 out, then I get dx of cos 5x squared plus 2. So I have this. This is what I'm talking about. So we can see that we factorized what? 3 out, which is very, very possible. Which is very, very possible. So the reason why I can or we can factorize 3 out is because there is no x term here. And if there is no x term here, it is what? Constant. And if it is constant, you cannot tell me that when you differentiate this 3 will go to 0. No, because it is what? Multiply. When we are adding, we can differentiate it with 10 by what? 10 using the sum or difference with rule. So now let's see. So my 3 is here. So now how do I differentiate this cos 5x squared plus 2 with respect to x? First of all, if we differentiate the whole of cos 5x squared plus 2, we get what? Get minus sine 5x squared plus 2. Take your time. When you differentiate the whole of this cos, when you differentiate cos 5x squared plus 2, you obtain it. Minus sine 5x squared plus 2 times we differentiate the expression inside the bracket. So dx of 5x squared plus 2. Differentiate the expression inside the bracket. We differentiate the expression inside the bracket. So now, I have 3 of minus sine 5x squared plus 2, then times we differentiate the expression. So when we differentiate 5x squared, we get what? 10x, right? Then when you differentiate the constant, it goes to what? 0. So I have minus 3 sine 5x squared plus 2, then times my 10x. Don't forget, this minus the rate is not what? It is multiply. So I can take this guy also to what? Multiply, right? But you cannot multiply this guy by that. You can multiply 10x by what? Minus 3. So negative 3, sorry, negative 3 times 10x will be negative 30x. Then minus sine 5x squared plus 2. So this is how it is. So you differentiate that with respect to what? X. The reason why this guy, you differentiate the whole of what sine x, you get what x. Then you differentiate the expression. Sorry, you differentiate the expression here inside the bracket, which is x. You differentiate it with respect to what x. When you differentiate that, you get 1. So that's the reason why we do not see that, right? So 1 times cos x is the same as cos x. Right? Okay. Let's move on to our next question. All right, so let's see this question. Question 4. Cos cubed x. Cos cubed x. So now we want to differentiate that. So we differentiate with respect to x of this cos cubed x. So now, this guy, we can write it as cos x or x to the 3. Right. Don't forget, we can use the chain rule here. We can use the chain rule. You can use the chain rule. Or better still, you don't want to use the chain rule. I told you a technique. This 3 multiplies that. Right? So this 3 it drops. So 3 times minus x. Then we subtract it 1 from the exponent. Right? Then times we differentiate cos x. So when you differentiate cos x, you get minus sine x. So I get 3 cos x all to the power of 2. Then times my minus sine x. Now cos x all to the power of 2 can be written as cos squared x times minus sine x. Now with this, I can write it as negative 3 cos squared x sine x. That's how it is. Again, I differentiate cos cubed x with respect to x. And this cos cubed x can be written as well. Cos x or exponent 3. Cos x or exponent 3. Then how do we differentiate this? We differentiate using the chain rule. Don't forget, using the chain rule. This 3 drops, right? Then you multiply it by the expression cos x or the trig function, sorry. You multiply it by the trig function cos x. Then now we subtract 1 from the total power or the total exponent, which is 3. We subtract 1. So I have 3 minus 1, then times, we differentiate the trig ratio here, cos x. We get what? Negative sine x, right? So I have 3 cos x all exponent 3 minus 1, we get 2 times negative sine x. So this guy, cos x all exponent 2, can be written as cos squared x. So now, cos squared x times negative sine x. Multiply, negative multiply this 3. This 3 is not an angle. So negative multiply this 3. So you get negative 3 times cos squared x sine x. Times sine x. So now let's see the next example. Alright, let's see. 2 cos squared x squared plus 1. Don't forget, we have no x here, so this guy is a constant, and it is multiplying, so we can factorize, right? So I factorize 2 out, then I differentiate that with respect to what? X. So I have this. Let's see, how do you differentiate cos squared x squared plus 1 with respect to x? Now let's see. So I have 2. Now, this cos squared x squared plus 1 can be written as what? I still have my dx. Can be written as cos x squared plus 1 or squared. It can be written as this. Right. So I have 2 times, let's see, we are differentiating. We can use chain rule, but let's use our scale here, our shortest procedure. So I say 2 drops. So 2 drops down. So I have 2. Then our cos x squared plus 1. Then we subtract 1 from the exponent. Right? So I have something like this. We subtract 1 from the exponent. Then times differentiate cos x squared plus 1. When you differentiate that, you get what? Negative sine what? X squared plus 1. You get negative sine x squared plus 1. Then times the expression. You differentiate the expression inside the what? The bracket. So we get to 2x. So now I have my 2 times my 2 cos x squared plus 1. Then I have my negative side what x squared plus 1. Then times what our 2x. So now let's see. 2 times 2 we obtain what? 4. Then times this one, 2 times 2, 4, 4 times 2 is we obtain 8x. Then our negative here, cos x squared plus 1, then sine x squared plus 1. That's the answer. That's the answer. But we do it again so that you get it very, very well. Let's do it again. So now let's take it again. So I have want to differentiate. I said here there is no extend here, right? There is no extend here, and this 2 is multiplying that. So we can factorize 2 out. Then we differentiate with respect to x of what? Cos squared x squared plus 1. Right. And this one can be written as what? Cos x squared plus 1 all squared. So we have this. Right. So let me use this as my big bracket here. So we have big bracket here. Right. So now let's apply. Let's apply here. So we want to differentiate. Take your time, right? You want to differentiate. So first of all, if you want to differentiate these 2 is here, right? So 2 comes down. So I have 2 times multiply by what? Cos x squared plus 1. So cos x squared plus 1. Then we subtract 1. Right. Then we differentiate this trig ratio here, which is cos x squared plus 1. So when we differentiate cos x squared plus 1, we get what? Negative sine x squared plus 1. Right. Then times we differentiate the expression inside the bracket. So I get, when you differentiate x squared, we get 2x. And when you differentiate 1, we get 0. So we have this. So now let's see, 2 big bracket. Now 2 times 2x, then our negative, we get negative 4x. Then I have my cos x squared plus 1. We subtract to get 1. Then sine x squared plus 1. Right. So now we can multiply. So we get negative 8x cos x squared plus 1 sine x squared plus 1. So this is our answer. So don't forget. It's very, very simple and very, very trivial as well. Let's move on to the next question. So now let's see sine x cos what? 2x. Now we can see that here we have x10 here. Here also we have x10 here. And we are what? Multiplying. So we can apply what our product u. So the whole of this is what u, and the whole of this is what v. So let's apply. I have u dv over dx plus v du over dx, right? So my u is sine x, then my v is cos 2x, right? So now we differentiate u with respect to x. So we get, when we differentiate sine x, we get cos x. Then when you differentiate v with respect to x, don't forget, let's differentiate cos 2x. When you differentiate cos 2x, you get negative sine 2x. Then times you differentiate the expression inside the bracket. So when you differentiate 2x, you get what? Positive 2. So my dv over dx equals negative 2 sine 2x. Right. So now let's substitute that in the formula. So my u is what? Sine x. Then dv with respect to x, we get negative sine 2x. So we get negative 2. We get times negative 2 sine 2x. Then plus our v is cos 2x. Then times our du with respect to x, we get cos x. So I have cos x. So now, let's see. Sine x times negative 2 sine 2x. We get negative 2 sine x sine 2x. Then this guy, we get plus cos 2x cos x. So we have this. We have this, which is very, very simple and very, very trivial as well. Always, I said your sine x is what? U, your cos 2x is what? V. They are multiplied. So you use the what? The product what? Rule. Right. So my u is sine x, my v is what? Cos 2x. You differentiate u with respect to what? X, you get cos what? X. You differentiate v with respect to x, you get negative sine 2x. Then you differentiate the expression inside the bracket, which is what? 2. So we get your negative 2 sine what? 2x. So now we have our u, we have our v, we have our derivative of u, we also have our derivative of what? V. You substitute it into the product rule formula. Our product rule formula is PR. So our u is sine x times our dv is negative 2 sine 2x plus our v is cos what? 2x times our derivative of u with respect to x is cos x. We multiply, we get negative 2 sine x sine 2x plus we multiply and we get cos 2x cos x. Let's see our next example, okay? Take your time and watch it very carefully. Alright, so let's see. 2x cubed cos 3x. You want to differentiate. Take your time. It's very, very simple. Take your time. It's very, very simple. 2x cubed cos 3x. Now, with, I think, is it this example, you can see that 2, there was what? No x term available. But here, see, we have x term here available. So we cannot factorize 2x cubed out, right? So now, since here we have x term here, we also have x term here. We cannot differentiate with respect to x using the product u. So we use our product u dv over dx plus v dv over x. Now, the whole of this is my u. The whole of this is my u. So our u equals 2x cubed. Then our v equals cos 3x. Right? So we differentiate u prime with respect to x. We get 6x. Don't forget. 3 multiplies to get 6. Then we subtract 1. then v prime, you get, now let's see, when you differentiate cos 3x, you get negative sine 3x times the derivative, don't forget, of the bracket, right? Differentiate, so you get 3. When you differentiate 3x, you get 3. So our v prime should be equal to negative 3 sine 3x. So we have this, right? So now we have our g, we have our v, we have our g prime, we have our v prime. We can substitute. So our g is 6x times our v prime is negative 3 sine 3x plus our v is cos 3x times our u prime is 6x, right? So we can get negative 3 times 6x, we can get negative 18x sine 3x. Then this guy plus you get 6x cos 3x. So we have this, which is very, very simple and very, very trivial as well. Your u is 2x cubed. Why? Because this time around we cannot factorize 2x cubed out. Because we have x term here and they are multiplying. So we can use our product rule. Our product. So don't forget. Don't forget. It is very, very simple and very, very trivial as well. Now let's see our next example. So let's see tan x over x. How do we solve tan x over x? Now this, we can apply our quotient rule. You can also apply your product rule. When you massage it, you can apply your product rule. Right here, let's apply our quotient rule. Don't forget, our quotient rule, this one is u, this one is v, right? So we hold v constant, then we differentiate u with respect to x, minus we hold u constant to differentiate v with respect to x, divided by v squared. Right. So now let's see. Our u equals tan x, then our v equals x. Our u prime equals, when you differentiate tan x with respect to x, you get what? Sec squared x. Then when you differentiate v with respect to x, you get 1. So let's substitute into our formula. V is x, then times differential of u, we have sec squared x, then minus our u is tan x, then differential of v, we get it 1, divided by, what is our v? Our v is x, so x all squared. So let's see, we multiply, get x sec square x, then minus tan x, all divided by x squared. So that is our final answer, which is very simple and very, very trivial as well. So you can see the number of questions I've solved. I've solved 1, 2, 3, 4, 5, 6, 7, 8. So I've solved 8 questions. 8 questions. So we are left with 7 questions, right? But don't forget, I'll leave some for you to solve. Let's solve our last question, which is question 9. Question 9. All right, so let's see. Cos 2x divided by sin x. We solve using our quotient rule. Using the quotient rule. Using the quotient. So let's see. Using our quotient rule. So our quotient will say that v u prime minus u v prime all divided by v squared. Right? So our v is Now let me start with our u. Our u is cos 2x. Then our v is sine x. Now let's see u prime. When you want to differentiate u with respect to x, let's see cos 2x. Cos 2x, I differentiate this cos 2x. When you differentiate that, you get negative sine 2x. Then time, don't forget the derivative of the expression inside. So we get to 2, right? So our u prime can be written as 2 times negative 1, then negative 2 sine 2x. Then v prime, when you differentiate sine x, is simple as well, cos x. Right? So now, let's apply our formula. What is v? V is sine x. Then times what is our u prime? Negative 2 sine 2x. Then minus what is our u? Our u is what? Cos 2x. Then times what is our v prime? Our v prime is what? Cos x. Divided by our v is what? Sine x, so sine x all with square. So we can rewrite it as negative 2, we get sine x sine 2x, then minus cos 2x cos what? X, cos 2x cos x. You get minus, let's say cos 2x, then cos x, divided by sine x cos square root of sine square root x. So we have this, which is very simple and very trivial as well. Thank you for watching and thank you for subscribing. Alright, so now let's see our questions left. We are left with this, 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 and we are left with this, and we are left with this. So the ones I've marked with your asterisks, you are going to try it yourself. You are going to try it yourself. So you kindly make sure to try it very, very well and drop it at my comment section, or you can WhatsApp me on 0541086482. I'm looking forward for your answers and your questions. Thank you and have a nice day. Bye.